Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and greetings everyone. So today we are from group F, which is gonna present about discrete mathematics mini project that's conducted by Dr. Arif bin Mandangan. So before that, I'm introduce you about our group F, our members. So the first members is which is me, conduct by me, Muhammad Khalid bin Lalim, Chok Shin Xiong, Indrina Afira Hiskia, Nurin Iman Jasmine binti Abdullah, Hanan binti Muhammad Termizi, Muhammad Osama Anas bin Muhammad Osman. So today we gonna present about you and explain and brief to our beloved lecturer, which is Dr. Arif, and to all our fellow friends about 6 questions that we choose for our mini project discrete mathematics. So for the chapter 5 question, which is counting, we choose question number 1, question number 3, and question number 4. So I'm passing to the next presenter.
Assalamualaikum. I will be presenting question 1 from chapter 5. In how many ways can a photographer at a wedding arrange 8 people in a row, including the bride and groom, if A. The bride must be next to the groom, B. The bride is not next to the groom, and C. The bride is positioned somewhere to the left of the groom? A. If the bride must be next to the groom. If the 8 people were to be arranged without any restrictions, the solution is 8 factorial, which equals to 8 multiply 7, multiply 6, multiply 5, multiply 4, multiply 3, multiply 2, and multiply 1. And this gives 40,320 ways. Now, you want to arrange the 8 people, but the bride must be next to the groom. So for this, we assume that the bride and groom is one person. So this leaves us with 7 people to arrange. Therefore, 7 factorial, which equals to 7 multiply 6, multiply 5, multiply 4, multiply 3, multiply 2, multiply 1. And this gives us 5,040 ways. Then, 5,040 multiply with 2, and then we will get 10,080 ways. Question B. If the bride is not next to the groom, the number of ways to arrange the 8 people with no restrictions minus with the number of ways to arrange 8 people but the bride must be next to the groom will give us the answer to the number of ways to arrange the 8 people but the bride is not next to the groom. Therefore, 40,320 minus 5,040, we will get 35,280 ways. C. If the bride is positioned somewhere to the left of the groom. Now, if the 8 people, including the groom and bride, are arranged without any restrictions, there will be 40,320 ways to arrange. Half of these ways must be the bride being on the right side of the groom, and the other half the bride being on the left side of the groom. So, the number of ways to arrange the 8 people without any restrictions divide into 2. So, 40,320 divide into 2, we will get 20,160 ways.
Continuing in question 3, the English alphabet contains 21 consonants and 5 vowels. How many strings of 6 lowercase letters of English alphabet contain A. Exactly 1 vowel, B. Exactly 2 vowels, C. At least 1 vowel, and D. At least 2 vowels? For exactly 1 vowel, the location of the vowel can be chosen in 6 ways. For each choice of location, the location can be filled with a vowel in 5 ways. That leaves 5 empty locations, which can be filled with consonants in 21 power 5 ways. That gives a total of C times 5 times 21 power 5. So there are 122523030 strings containing exactly 1 vowel. For exactly 2 vowels, the location of the vowels can be chosen in 6 C2 ways. For each choice of location, the location can be filled with vowels in 5 power 2 ways. That leaves 4 empty locations, which can be filled with consonants in 21 power 4 ways. That gives a total of 6 C2 times 5 power 2 times 21 power 4. So there are 72930,375 strings containing exactly 2 vowels. For at least 1 vowel, there are 26 power 6 6-letter words, and there are 21 power 6 all consonant words. So there are 26 power 6 minus 21 power 6 words that have at least 1 vowel. So there are 223149655 strings containing at least one vowel. For at least two vowels, an efficient way is to count the words that have 0 vowels or 1 vowels and subtract from the total number of the words. This approach let us recycle previous result, and recycling is a virtue. So, take the total number 26 power 6 of words and subtract the 21 power 6 all consonant words and the number of exactly one vowel words we are already calculated. So, 26 power 6 minus 21 power 6 minus 6 times 5 times 21 power 5. So, the answer is 100,626 625 strings.
Moving on to the question 4. First, let's have a look on part A. Given that a plus b to the power of 7 and the question asks us to find the expansion of it. So all we gotta do is simply using the binomial theorem as shown here and insert all of the terms accordingly. Now from the formula, which is x plus y to the power of n, it's represented by a plus b to the power of 7. Next, from the equation obtained, we can simplify it using scientific calculator to find the coefficients of each terms. For instance, 7 choose 2 is equal to 21. Therefore, we can put the simplified equation as our final answer. For part B, we need to find the coefficient of b to the power of 9 in an expression of 2 minus b to the power of 19. Same goes to the previous one. We need to find the expression of the coefficient from the given terms using binomial theorem. And as we can see from the red marks there, that's the expression of b to the power of 9. We can stop expansion there if we want. Next, we can compute the equation and simplify it. So, from there, we can calculate all of the numbers to find the exact coefficient of b to the power of 9. Moving on to the part C, which quite similar to the one in part B, since this question asks us to find the coefficient of a to the power of 101, b to the power of 99 in the expansion of 2a minus 3b to the power of 200. First thing first, we need to find the expression of the coefficient from the given terms using binomial theorem, and we obtain 200 choose 99, 2a to the power of 101, negative 3b to the power of 99. We can leave the final answer in an expression of an equation, since the value can be computed in calculator, meaning to say negative 200 choose 99 will give math error. Therefore, the coefficient here is negative 200 choose 99, 2 to the power of 101, 3 to the power of 99, or we can simplify it in this form. Lastly, for part D, where we are required to give a formula for the coefficient of a to the power of k in the expansion given. In order to do that, we need to refer to this formula and substitute the value accordingly. As we substitute the value, we can simplify the equation obtained and do the comparison, since our goal here is to find the value of r. At the end of calculation, we can express the formula in this form. That's all from me, thank you.
So, we move to the chapter 6 question, which is we choose the question number 1, question number 3, and question number 4. So, let's move to the question number 1, which is suppose that 150 people enter a contest and that different winners are selected at random for first, second, and third prize. What is the probability that Ahmad wins one of this prize if he is one of the contestants? So, we have two big steps here, which is the first step is we need to find the probability of first prize, second prize, and the third prize. And the second step, we need to find the probability of Ahmad win based on our first, second, and third prize probability. So we move to the first big step, which is we need to find the probability of first prize and second prize and the third prize. So we assume that J first prize, K for the second prize, and L for the third prize. From the question, we get the sample size is 150. So here we assume that the probability of winning first prize is taking only one contestant out of 150. So the first prize of So the probability of first prize is 1 over 150. Next, the probability of winning the second prize is taking only one contestant out of 149. So the probability of second prize is 1 over 149. And lastly, the probability of winning the third prize is taking only one contestant out of the 148, because for the first prize we had one contestant, for the second prize we had one contestant, and for the last is third prize we had 1 over 148. So the probability, so the first step we have done. So the next step is we need to find the probability of Ahmad win one prize, which is here we assume that A is Ahmad win one prize. Okay, so the probability of Ahmad win is probability of first prize plus probability of second prize and plus probability of third prize. So the answer is 1 over 150 plus 1 over 149 plus 1 over 148. So we get the answer 0.021035. So we simplify it, we simplify our answer, so we get the answer is 0.02, or we get the answer 1 over 50. So that's the answer for the first question. Thank you. So I'm passing to the next presenter. Thank you.
Alright, for question number 3, chapter 6, find the probability of each outcome when a die is rolled. If rolling of 2 or rolling if 4 is 3, like times as likely as rolling each of the other 4 number on die, and it's equally like to roll a 2 or a 4. Okay, for the answer for solve this question, consider probability equal to probability of getting of other 4. So the probability can be number 2 or 4. Equal 3, 4 probability equal 12 probability. So that we get P2 plus P4 equal 3 times P1 plus P3 plus P5 plus 6 equal to 12P. So the sum of the probabilities must be equal to 1. So probability 1 plus P2 plus P3 plus P4 plus P5 plus P6 and equal to 1. Probability plus 12 probability plus P plus P plus P and equal to 1. So equal to 16P equal to 1. So probability equal to 1 over 16. So the probability of getting number 1, 3, 5, 6 equal to 1 per 16. For number 2 and 4, 12, we get equal to 12 per 16. So 1 per 2 equal to 6 per 16. So the final answer for P1 we get 1 over 16. For P2 we get 6 over 16. P3 we get 1 over 16. And P4 we get 6 over 16. P5 we get 1 over 16. And lastly P6 we get 1 over 16.
Okay, so now let's check out our solutions for the fourth questions. According to the questions, there are 2 dice, and for the first dice, the probability to get number 4 is 2 per 7, and for the second dice, the probability to get number 3 is also 2 per 7. Meanwhile, for the other numbers in each dice, which is number 1, 2, 5, and 6, the probability to get these numbers are 1.1 per 7. The questions ask us to find the probabilities of the number 7 appearing as the sum of the numbers when the 2 dice are rolled. Okay, so the strategy here is we need to list out all of the possibilities to obtain 7 has the sum from the two dice. So as we can see here, in order to produce 7, there are 3 ways, which is 1 plus 6, 2 plus 5, and 3 plus 4. Now we just need to multiply the possibilities accordingly, and most of the pairs will give 1 per 49 as the outcomes, as we multiply 1 per 7 together. But as I mentioned earlier, probability of number 4 and 3 from the first and the second dice respectively is equal to 44 per 7. So when we multiply it, we get 4 per 49. Finally, we need to total up all the probabilities to obtain the final answer of the probability of 7, which is equal to 9 per 49. That's all from me. Thank you.
So we move to the next session, which is the question and answer question. So I would like to I would like to ask Osama, in your question, which is the part A, can you show me how to compute the combination equation in calculator?
Alright, thanks for that question. Regarding the part A, which is it asks us to expand a plus b to the power of 7, where realistically it's going to take time if we expand it one by one. Hence, this is where binomial expansion is our work since we can do it directly. Let me show it how it can be computed in calculator. So in our calculator, there's a symbol of NCR and we can use it to compute the combination equation. So from the question, let me give one example. 7 choose 1, we can compute it in calculator and it will gives an answer of 7. This combination equation derives from the factorial equation where it is just the same. And if we want to recheck, we can do the calculation of factorial there, where we can simply put 7 factorial divided by n minus r, which is 7 minus 1 will equal to 6 factorial. So when we divided this to factorial equation, we still get the same answer, which is 7.
I see. I understand now. So thank you. Thank you. Hanan?
Okay, can I ask questions?
Yeah,
Okay,
okay.
I would like to ask Hanan about question one. Why did you multiply 5040 with 2?
Okay, so to answer your question, why did I multiply 5040 with 2? So the answer is, because for each of those 5040 groups, there are 2 possibilities to arrange the bride and groom. The bride then the groom, or the groom then the bride. So that makes the total possible arrangements 5040 multiplied with 2, and that will give the answer 10,080 ways.
Okay, thank you. That's clear.
Okay. Any other question?
Okay, I'm asking question for Nurin. Nurin, can you justify again on your calculation for probability of number 2 and 4?
Yes, sure. Alright, as we extract the information from the questions, it started there that if rolling a 2 and a 4 is 3 times likely as rolling each other 4 numbers on a dice. So there are 4 numbers there which are 1, 3, 5, and 6. So therefore, we need to multiply 3 with 4 to obtain the probability of it. Alright, that's it. Does answer your question?
Yes, that's it. Thank you.
Okay, thank you everyone. So that's all from us. So thank you and have a good day.